There are a lot of things that we're going to discuss in this video which will not be repeated in other videos. So it's important for you guys to understand everything in this video. So we are looking at sine inverse of x. Let's start off with looking at sine of x itself. Sine of x can accept any angles, any input value, and it will map them to values like minus plus 1 in this case to minus 1, right? So this whole set of output will vary from minus 1 to 1. So basically I can tell sine of x maps any given angle or angles to values from minus 1 to 1. Now the inverse of sine will map minus 1 to 1 to any angle, right? Obviously this is the basic funda. Let's look at the graph of your sine inverse of x. So the graph along the x-axis we have minus 1 to 1. That's what we discussed over here, as you can see. And the output will have a lot of angles. It does have a lot of angle, but this leads to a particular error. What is that error? Let me explain it this way. If I have a input of 0.5 minus 0.5, for example. So this is your input, and we can see that it has a plenty of output. This is an output, this is an output, 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 output. There are plenty of output. There are 6 output itself over here. But when we look at the idea of functions, you know, the basic definition of functions, how does a function, how do we define a function? When does a relation become a function? A relation becomes a function when each input value maps to an unique output value, right? The key word here is unique. But we can say this is not unique. For one particular input, I have in this graph itself 6 of it. So with this definition, sine inverse of x, it won't be a function, right? We are talking about inverse trigonometric functions, but this is not a function as of the definition. So how do we make this as a function? Well, we fix the domain to minus 1 to 1. And we fix the output set to a particular set of values, and those set of values are known as branches. To help us navigate this weird scenario wherein we have so many outputs, you know, so many possible outputs, like so many over here. There are infinite possibilities actually. But for a function or relation to become a function, we need to have a particular output. To help us with this, we make use of, we make use of branches. So what are branches? So obviously they have to do with output. So let's look at the definition. The branches of inverse trigonometric function are different ranges of function that produces unique output values. What does it mean? Let me show it in the graph. Let me go to the start. So my bad, this is actually not, this is for cos actually, this is not sine. But anyways, both look the same. This is your sine. Right, we have the same scenario. If I give an input of minus 0.5, I get so many possible outputs, right? So how do we resolve it? With the help of branch. So let me give an idea of branch now. See, if I start from this value, that is minus 7 pi by 2. If I move on to minus 5 pi by 2. So this slider helps me move along the y-axis actually. Vary the y coordinate and the x coordinate will be automatically calculated. Now I moved from minus 7 pi by 2 to minus 5 pi by 2. What can be my input? it will cover all my input 1 till -1. So a value, a range starting from minus, I think it is 7 pi by 2 till minus 5 pi by 2, we are able to cover all the input values, right? Now let me move from minus pi by 2 to, so it's starting from -1. So next point is still 1. So -1 to 1, right? That is minus pi by 2 to minus 3 pi by 2. This 2 is able to cover minus 3 pi by 2. This 2 is able to cover all the input values, right? Next, if I move from minus 3 pi by 2 to minus pi by 2, again all my input values are covered. Then we have minus pi by 2 to pi by 2, that is one more possibility, minus pi by 2 to pi by 2. So if I keep going, then I'll get things like, I think we'll have 7 pi by 2 to 9 pi by 2. Again, there are infinite of possibilities. I'm just writing random ones. So each of this called as a branch. So by picking the domain to be whatever it is and one of the branches, we can convert the sine inverse of x into a function by picking a branch and of course and -1 to 1 as a domain, sorry, range actually, no, this is domain. These are your ranges, right? We get to convert sine inverse of x into a function. That's the whole idea of a branch. Okay, if someone tells me, you know what, I'll give you an input of -0.5. What is the output? And I'll ask them, okay, you know what, tell me the branches. Okay, this is not right. This graph is wrong. If I ask them, what is a branch? If I ask them what is a branch, and if they tell, you know, I'll give you a branch of -5 pi by 2 to 7 pi by 2, then my output will be over here. This is my output. If they tell no, the branch is -5 pi by 2 to 3 pi by 2, then that would be my output, so on and so forth. So depending on the branch, it has to be a particular branch. If not, you won't be able to tell the answer. But if they tell, you know what, it's okay, you can choose the branch, or you can choose the standard branch. The so-called standard branch is actually your principal branch. Whenever we pick up a calculator and calculate the sine inverse of some value, it will give a particular value, and that value will be a branch. It will be a value in a particular branch, and that branch is, can you guess? I've written it on the screen. The third one. Okay, -5 pi by 2 till, not 5, sorry, -pi by 2 till pi by 2. This is your principal branch. Why is it a principal branch? The reason behind it, if you guys understand the unit circle concept, if you learned your basics properly, then this will make sense. Again, things should make sense, things should be relevant, only then it will be easy to remember. Okay guys, so this is basically your introduction to sine inverse of x, how things happen with sine inverse of x. So final thing is, we need to draw a graph that will help us. That's your input, your domain, and your range. This is your range, and this is your domain. Okay, so your domain will vary from -1 to 1, and your range will vary from -pi by 2 to +pi by 2. So When we have minus 1 as the input, I'll get minus pi by 2, and this would be plus pi by 2, and the graph would look something like not exactly that, but yeah, that's the best I think as of now I can do. Not good. That's decent. So that would be your graph for sine inverse of x. Okay guys, so please copy everything. If you want to rewatch, please do rewatch, because the idea of branch is very important.